In this chapter, we'll be covering ground control points. What the objective is to gain some fundamental understanding of georeference and the control points. And we're going to learn about the structure of GCPs, coordinates, and become familiar with the image marking techniques that are unique to Pix4D, and to comprehend how to tie the imaging that we capture to the GCPs. The project's georeference is a critical component because it answers the question, where does my project exist? And a project may be referenced to some absolute location on Earth, an absolute location in an arbitrary world, or be completely independent from a defined reference. The default setting for Pix4D Mapper's photogrammetry algorithm depends on the dense image matching of similar pixels between the photos. Now, this is made possible due to the high redundancy of the image context thanks to the image overlap. So we're overlapping images, maybe even 70%, let's say, and that will allow Pix4Ds to be able to align and orient images strictly based upon this overlap, which in turn enables the generation of what they call ATPs, or automatic tie points. Now, these dense image mapping and the ATPs occur in the subsequent order during the process of what they call step one. So in step one, this is when that image mapping and automatic tie points occur. Now, if no georeference is provided, the ATPs, or the resulting deliverables, will not contain a defined reference. Now, this means that coordinates will be based on an independent 3D plane that is unique to that specific project. The most commonly provided georeference is known as the direct georeference, or the DG, obtained from the image geotags. Now, each image is tagged with a unique latitude, longitude, and altitude, which is copied to the image metadata. And then during step one, Pix4D Mapper accounts for the DG of each image to provide an absolute georeference to the project. Now, a concern about DG is that the absolute accuracy of the georeference would be based on the absolute accuracy of the drone's GPS or GNSS units. Units are known as consumer grade, meaning they meet the needs of flying the drone autonomously, but are imprecise by a number of meters unless the drone is capable of DG via the RTK or PPK. This is fine if the project does not need to meet very strict accuracy standards, such as those outlined by the American Society of Photogrammetry and Remote Sensing, ASPRS. When DG does not meet accuracy standards, ground control points, GCPs, must be implemented. GCPs are 3D coordinates of the Earth's surface collected by a professional land surveyor using survey-grade GPS or GNSS equipment. Now, each coordinate is shot over a center of a target, which will later be identified in images. The control is then tied to the image to provide an accurate, absolute georeference. If both DGs and GCPs are implemented in a project, the GCPs will override the DG, which will provide a more accurate, absolute georeference of the project. So in this chapter, we will learn the technique of marking targets, and we'll also tie the control to the project to ensure the project maintains a georeference. Now we're going to be working with a pre-processed project. The data file and the images are located in the L3 data zip file. Now, you should have this file on your desktop, and if you don't, ask your professor or download it to it. The next step is what we're going to do is extract the data off of this. So we're going to open that one up, and we're going to do a full extraction. And then on the L3 data, what we want to do is we're going to move that over to your previously made up of your last name Pix4D file. Okay. And then we'll wait for this to copy over. And once this is complete, you can open up your main file, and if you notice, you have an L2 data and an L3 data. Do not confuse these. We'll be working strictly with the L3 data. So if you open this one up, the L3 data, you'll see images, an O1 images, an O2 project, and an O3 control. If you open up the O2 project, you're going to see the GCPs in a reference of a Pix4D file. Now we're not going to be creating a new project because this is a pre-processed project. So if we just double click the L3 GCP Pix4D file, it will actually bring up Pix4D Mapper. Now it does not save in this database, you could say, the images, so we're going to have to tell it where the images are. This will happen anytime our projects get transferred from one computer to another. So we're just going to click OK. And then we're going to navigate to the image ones. It's in the L3 projects. Okay, so we're going to take a look at the data. And then what we're going to do is, there's our images. So we're going to select that one. And we're going to select that folder because that's where all our images are within this data. That's under your file. And then the L3 data. We're not doing L2, just L3 data. And then within that is the O1 images. So we're going to select that folder. And it will start loading the project. Now the software now basically references this path for this particular project. The GCP project will open and display the map view as what you're seeing here. The project was flown over a small park in California. Then let's go up to the Ray Cloud, which is right below the map view, and take a look at that. And now what we see is the images and the automatically the ATPs. So at this point, the automatic tie points are created. Now, the Pix4D can import GCP coordinates from either a projected coordinate system or a local coordinate system, such an arbitrary one. For this project, the GCPs were projected to this California State Plain Zone 3 coordinate system. All units are in feet in this particular case. To look at this, let's go over and let's open up the L3 data. And we're also going to take a look at the control file. If we open that up, and then we're going to open up the folder. If you notice in the folder, the text, this is a TXT file or text file. It's separated by commas. Each comma is read as a delimiter in Pix4D Mapper. This type of text file is known as a common separated values or CSV file. GCPs must be recorded in this fashion to be implemented in the software. Now, the commas delimit the following information. The first one is, if you notice, it says ID. Underneath that, it's numeric, so we have an ID of 1 through 4. The X one is the easting coordinates. It's equivalent to the longitude. The Y is the northern coordinate. It's equivalent to latitude. And Z, the last one, is the elevation coordinate. A CSV with the ladder delimiters is all that's needed for GCPs. So this is it. This is all we need to bring in GCPs. You can also note that the coordinates may be ordered into northern, eastern elevation, or YXZ. But now let's go back to the Pix4D Mapper. For L3, the GCPs has already been imported. So verify this by clicking the GCP MTP Manager button located on the top left of the screen. The GCP, this manager window will then open. Now you can verify that the GCP coordinate system is the same as stated above. So if you notice, it actually states this coordinate system. North America Denim 1983, coordinate system NAD 1983, State Plane, California. That verifies that the coordinates are delimited and that they match with the text. The coordinate values in each cell may be modified. So you can actually modify these cells if you wish. If the GCPs were not present in a project, it's possible to import them by clicking the Import GCP button. When prompted, then you select the text file which contains the coordinates. However, for this particular process in this chapter, do not import the GCPs again, as it's already been accomplished. So let's go ahead and click the Cancel button and to close that dialog. Now also remember that GCPs do not automatically tie the images to the control as soon as they're imported. They are tied by manually identifying the center location of the targets via a technique in Pix4D called marking. So to start this, let's first locate the GCP MTP layer windows. So if you see the layer and you look at, here is the GCPs, let's take the caret and expand that out so that each ID for each GCP is member of that. When we looked at the file, there were 4 of them, and here's the 4, and they're marked as 1 through 4. Notice the labels, basically, they are identical to the text file. The 0 to the side of each ID is an indicator of how many images have been marked for each individual GCP. Now the goal of this exercise is to increase those numbers by marking images. So if we select 01, okay, from the layers window, the layer should highlight when selected, and it does if you notice it's highlighted. The selection is expanded, but for right now, let's close it so all we see is the images in the window. Each thumbnail, if you look at each thumbnail here, represent an image which the software identifies as a corresponder to the selected GCPs. So let's pause here before we continue on with this, and let's if we take a look at the screen down below in the center, and if you notice as I move it around, you'll see this little highlight on the top part. All of these are basically automatic tie points. So Pix4D, from these camera shots up here, they actually seen where the overlap, and they identified a point that tie the 2 images together. And these are automatic tie points. But as you know, and as we've discussed, these do not have, they are arbitrary in that they do not have a specific location to it other than the general one that's hidden in the metadata of the image, which is inaccurate. So what we're doing is, previously what we've done out there is what we've surveyed GCPs, and we put these targets. So these are actually targets that we actually put out on the area and surveyed it to have accurate GCPs, of which we have 4 of them out there. And what we're doing now is we're going to adjust the image. So if you noticed, the bullseye in here, these bullseye is the position of the GCP coordinates, which are known as initial positions. Now they're shifted slightly from the center, as you can see. Now this is an indication of the inaccuracy of the image shots that were collected directly on top of the image center. Now by marking these images, we will override the initial position so that the images and control will be tied together more accurately. So if we roll our mouse over an image, you notice that there's an orange square that will outline this. Then if you hit the space bar, the image will expand to full scale. And this should make it's a full scale on your screen, or what they call full extent images. This leverages the full extent, and we can zoom our mouse in even closer to the center, right down to the pixel. Okay. And then what we do is we we do our best to interpret the centers. And then once we identify, we left click it in your mouse and it should create a mark, which it does if you see that little X right there. The marks are distinguished by yellow crosses. So right about here would probably be the best for center. Okay. And we hit the space bar again for conclusion. And if you notice that we can also roll our mouse. Okay. Now we're going to repeat this process to the next image, and now the marks may be adjusted by simply left clicking any part of the image, and the last mark will really stick as the final. Now let's repeat the process until we've marked at least 10 images. A good rule of thumb is to mark between 10 and 15 images for each GCP. Now, before we do that, just remember that what's happening here is that with a GCP that has been integrated into this, Pix4D is gathering images up that have that coordinates in these images. And then we can then look at that, and then we adjust it to exactly dead center of our target. And this provides much greater accuracy to our project. So let's now continue on, and let's mark these. Again, we highlight it with the orange, hit the space bar. We can roll it in really close. Okay, try to find that center spot. Left mouse it, and then what will happen is this will show a ring plus a square. Hit the space bar again, and we're off to the next one. So let's go ahead and do those, at least 10, and then continue on. So I have about 12, 13 in there. Let's do a couple more here. And we'll rotate that down to get it approximate. It's about right in there. Hit the space bar again. We can roll that out just to see it. Hit the space bar after we highlight that one. Roll this thing down. Get the right pixel on that. Okay, there's about 15 or 16. So you can see what we've done here. Now some of these, which were way down where you can't see, I skip over it and try to pick up another one. But these are all the images that it determined that it could see it on that one GCP. So with that, you can actually, if you look at the thumbnail that you have here, I can actually move and tag it in the thumbnail if you want to. It's not as accurate as you can roll it in there, getting closer, but usually I like to expand it as much as I can. When finished, expand the selection menu up here, a window. The number of marked images is displayed in the window. Okay, so if you look at number of marked images, it says 16, so that's plenty. So what I can do in the most critical thing is to hit apply. If you do not, all this work that you've done is actually lost. So make sure that you confirm you have enough images, okay, under the selection window. After you mark all the images, you come to selection, confirm what you have, and then make sure that you hit apply. In addition, if you even adjust one mark, if you go back here and have to adjust anything else, make sure you go back into the selection and make sure you hit apply again, or it will be lost. Also notice in the layers menu, if you look at the GCP, it also says, if it's highlighted, it says there is 16 marked images And if you saw 0, or if you did something over here that's anything less than what you did, that means you did not hit the apply button. You have to go back and redo it. That's just why it's critical after you look at and mark your images, go into the selections, confirm what you've done, and then hit apply. Now let's go ahead and repeat this techniques for the remaining of O2. And when you're prompted with O3, when you get into O3, and I'll show you here momentarily, there you'll notice that a conventional target is missing. Okay, in its place is a corner of a handicap symbol. It's 100% normal to substitute target features that are fixed to the ground, as long as they're easy identifiable. And stripes are really a great example. So let's go on and let's mark all the rest of your GCPs. Now, as I mentioned, in number 3, the GCP number 3, you'll see a handicapped. And when what we're going to do, even though this is unconventional, it's still appropriate, because if they surveyed that exact corner, we have the GCP of that corner, and that target isn't going to move. So we'll take a look at the first one. We'll bring it up by a space bar. It's the inner right corner, which really we want it to be on the outer, so it's right about there. Okay. Go to the next one, bring it in, so it's about right in there. Next one, if you notice, it's the corners, the same corner. So let's bring it in, looks pretty close. And we do this for at least 10 to 15, and then continue on with O4. When you conclude this, be sure that you take a look at the display properties, and you'll see how many GCPs you have marked for each one. Make sure that it corresponds to what you were expecting. So basically what we're doing is we're marking at least 10 images for these four GCPs. Confirm them. And then there's another process that's necessary in order to complete the tie of images in control. In Pix4D, it's a simple command known as reoptimize. Now, what I want you to do is locate the reoptimize up in the process section, and you'll see this little symbol right there. And accepting the prompt by clicking the OK. So you do that. It says yes, the results of the first step of the product already generated. By starting reoptimization, existing results will be overwritten. We want to do that. You say yes. Now this is a crucial step in the Pix4D processing workflow. Reoptimize will effectively reset the project back the way it was after step 1. Therefore, ensure that you have performed all the techniques related to GCPs before processing steps 2 and 3. And you'll look to see on reoptimizing, it's you can see down on the bottom screen. Now, so Pix4D will run a subset of step 1. That's what you see at the bottom of the screen. And it completes the tie and eliminates the need to process step 1 all over again in its entirety. If the failure occurs, and sometimes it does, revisit the marks. The most common mistake is incorrectly marking the images. So it says done, regenerate quality report, and we won't want to do that at this point in time. So in this chapter, we learned about the coordinates, GCPs, and how to mark targets. The control was tied to the images via the reoptimization process. So now what I want you to do is click the project tab up there on top, save project as, ensure that you are in your O2 project directory. That's under the L3 data O2 project. Give the project, this particular project, give it your last name, underscore, L3, and then click the Save button. Now let's go back to our file, take a look at the L3 data. Okay, and just make sure that you have your Davis L3. It's a Pix4D file. So what I want you to do is you right-click this thing. Okay, send to. Send it to compressed folder. Okay. So now what this is a compressed folder of that project you've done. And then what I want you to do is take that particular file, put it in the zip, or deliver it to the professor. Now this completes the chapter.